In this lesson, we're going to look at absolute value inequalities, and we're going to start out looking at them graphically instead of algebraically. So when we have this inequality, it's saying the absolute value of x plus 4 is greater than or equal to 5. Graphically, what we see is we have the absolute value function. We want to know when it's going to hit 5. So if I look at 5 on the y-axis, we can find out when the function is actually equal to that value. And so it hits 5 when x is positive 1 and again at negative 9. The question is asking when it's going to be greater than 5. So all of these sections are going to be greater than 5. But we want to list that as the x values. So when we project this on the x-axis, we're looking at the x value of 1 and all the way to the right to infinity. And then the x value of negative 9 and to the left to negative infinity. So as we take that solution and write it in interval notation, it would look like parentheses, negative infinity all the way to negative 9 with a bracket. We're using a bracket because it did have the equal to for our inequality. Union, bracket, 1 to infinity. All right, again, another one, we have the absolute value of 2x minus 7. That's the function that's graphed here, and we want to know when it's going to be less than 9. So if I find 9 on my y-axis, we can see where it does intersect it, and it happens at negative 1, and again at positive 8. This time we're trying to find the values that are less than 9. So that's going to be this whole section here. When we look at only the x values and project it down, that's saying from negative 1 all the way until we get to positive 8. I'm going to have open circles since we don't have the equal to. We're just looking for when it's strictly less than positive 9. So our solution would say parentheses negative 1 to 8 in another parenthesis. The third one, the absolute value of x minus 1 is greater than or equal to negative 6. So I can find negative 6 on the x or the y-axis. And then it's never actually going to equal negative 6. If you remember when we talked about absolute value equations, an absolute value, the output is going to always be positive, so the absolute value cannot equal a negative 6. But it's greater than negative 6 for all of those values. It's always going to be above negative 6. So when we think about it graphically, it shows all of the solutions to be all real numbers. So we would write that in interval notation, negative infinity to infinity. Example 4 shows the absolute value of x plus 3 is less than negative 1. So again, I find negative 1 on the y-axis. But this time, we switched it to less than. So this function is actually never going to be less than negative 1. It's always above negative 1. And that's because the output of an absolute value will always be positive. So it's never going to be less than a negative. So our solution is no solution. Okay, so algebraically, let's look at how we solve these. When we have an absolute value equation, the first thing we need to do is get the absolute value part by itself. So we're going to isolate our absolute value, and then we'll separate it out into our two equations or inequalities, just like we did with regular absolute value equations. But it's going to change slightly different because we're working with an inequality this time. So when we separate out into the two inequalities, we had to negate the second equation. And when we negate an inequality, it flips the sign and it changes the right side to a negative. So if we look at this first example, I want to try to isolate this absolute value. that means I need to get rid of the minus 8 first. We can't do negative 8 minus 3 and combine these because this 3 is attached to the absolute value with multiplication. So we want to add 8 first to both sides and get negative 3 absolute value x minus 1 is greater than or equal to negative 24. Now we can divide by negative 3, and the absolute value of x minus 1 would flip that inequality sign since we're dividing by a negative, but turn to negative 24 divided by negative 3 is a positive 8. So we have isolated our inequality, or our absolute value now, and we can separate this out into two inequalities. And you want to show this part. The first inequality is going to stay basically the exact same, just without the absolute value. So it's going to be x minus 1 is less than or equal to positive 8. The other one, we still have x minus 1, but we're negating this inequality, which flips our sign to greater than or equal to a negative 8, and we negate the right side of the inequality. With each of these inequality symbols, we see a pattern that happens. And so when you have a less than or equal to, or just a regular less than, we're going to have an and inequality. You can think about if you see less than, it's less than. If you have greater, you're going to write or between them. So what that means is when I have this absolute value of less than or equal to 8, I'm going to use an and between this. An and inequality is shading in between the two values, and we'll see that in a second. So if I solve this, I get x is less than or equal to 9, and then add 1 here, I get greater than or equal to negative 7. On a number line, this would look like, here's my negative 7 and my 9. We're shading or closing in both of those circles because we have the equal to's. But we want to shade to the left of 9. So anything that's less than 9 is here, and it has to be greater than negative 7, so to the right of this. So that and inequality is going to look like in between these two solution values. We take that and write it in interval notation. So bracket negative 7 to 9 with another bracket. All right, number 2, we still want to isolate our absolute value. And right now we have this dividing by 4 that's outside of the absolute value. So we're going to do the opposite, which is multiplying by 4. So 2 minus 3w, the absolute value of 2 minus 3w is less than or equal to, we're multiplying by 4, so we get 8. We don't have to flip our inequality because we're not multiplying by a negative. So this stays the same inequality sign. And it's a less than, which means that this is an and inequality. So we have 2 minus 3w is less than or equal to 8, and 2 minus 3w, now we negate, so greater than or equal to, and negative 8. That's the biggest thing. So make sure that you're writing the first inequality with the original inequality sign. The second inequality is going to flip the inequality sign and negate the right side. So that's why we flipped this to greater than and made it a negative 8. So we solve this out. I'd subtract 2 from both sides to get a 6. Divide by negative 3. Dividing by negative flips the sign, so that makes that a negative 2. Then we do the same thing over here. So subtract 2. I get negative 10. Divide by negative flips the sign and gives me a positive 10/3. You do want to just keep these as your improper fractions. Let's put those on a number line. Negative 2 is smaller, so it goes back here, and then 10/3 goes to the right. we get to fill in both of those circles since it has the equal to. And we just look at the direction. So W is greater than -2, so it's greater goes to the right, and it's less than 10/3, so to the left. We're looking at the values between those two numbers. So our solution would say bracket -2 to 10/3 with another bracket. All right, example 4. We have our absolute value already isolated, so we can go straight into our two inequalities, but we have a greater than symbol, so it's greater, makes that an or between the two things. So I have 4 minus 3c is greater than 6. The first one stays the same. The second one, I flip our inequality, so now it's less than, and we negate the right side, so less than -6. All right, let's solve this out. I'd subtract 4. 6 minus 4 is going to be 2. Divide by -3 makes that flip our inequality sign, so 2 divided by -3 is just going to be -2/3. Or, and then we do the same thing over here, so less than -10. Divide, we have to flip our inequality when we divide by negative, which makes that 10/3, a positive 10/3. And we put those two things on a number line. So -2/3 and a positive 10/3. We're not filling in the circles, they're open this time since we did not have the equal to part. But then we're looking at greater, or we'll go in the opposite direction. Think less than -2 is going to be this way, and greater than 10/3 goes to the right. So I'd kind of think of these as oars of a boat. The oars of a boat go to the outsides of the boat, and that's what's going on here. So we write our solution in interval notation, and it would say -infinity to -2/3 with a parenthesis, union, parenthesis, 10/3 to infinity. All right, example 4. We still want to isolate the absolute value. And what's going on here is multiplication. I see a lot of students that will just add 4 to both sides, but that's being multiplied to the absolute value. So the opposite would be dividing. So we want to do 4 minus x. The absolute value of 4 minus x is less than or equal to a positive 3. We divided both sides by -4, which made us flip our inequality to a less than. And then we can separate these out. So we keep the first one the same. 4 minus x is less than or equal to 3. And remember, it was less than. So then we have 4 minus x is greater than or equal to a -3. So we flip the inequality and negate the right side. Then we solve it out. So I subtract 4. 3 minus 4 is -1. Divided by a negative would flip our inequality sign. So x is greater than or equal to a positive 1. Then we do the same thing over here. So I subtract 4. Subtracting doesn't flip our sign. Subtract 4 gives me a -7, but dividing by -1 does flip the sign to make that a positive 7 there. If I put those on my number line, we get +1 and +7. They're both equal since they both have the equal to sign. So we have a closed circle. I want the values that are greater than 1, that's to the right of 1, and less than 7, so to the left of 7. That gives me this shaded region. So, and inequalities will usually look like this, where they're shaded in between. So our solution would be bracket 1 to 7 with both brackets on each one. Okay, So why don't you go ahead and try number 5 and 6. You can pause the video and then check your work. All right, if you already tried 5 and 6, what you did was added 8 to both sides. So that became a positive 4. You've isolated the absolute value, so I can separate this out. It's 2c plus 6 is greater than 4. It wasn't or because it's greater than. Then we had 2c plus 6 is less than negative 4. So we had to flip our inequality and negate the right side. And we solve each one of these inequalities. So subtract 6 makes that negative 2. Divide by 2 is negative 1. Notice I didn't flip the sign. We only flip the sign if we multiply or divide by a negative, and we divided by a positive 2. So then subtract 6 gives me a negative 10. Divided by 2 gives me a negative 5. So I find my solution region at negative 5 and negative 1. Make sure you put them in order. They both have open circles. All right, greater than negative 1 would be to the right. Less than negative 5 goes to the left. So our solution region would be negative infinity to negative 5, parenthesis, union, parenthesis, negative 1 to infinity. And if you finished number 6 already, you would have subtracted 4 first. You cannot combine 4 and 5 right now. All right, just think of that absolute value as a different type of expression. So 4 plus 5, let's say w, is greater than or equal to 0. There's no way that we could combine that to make that 9w. So you have to get rid of the 4 first to be able to isolate the absolute value. So I'd have 5 absolute value 2y minus 7 is greater than or equal to a negative 4. So we subtracted 4, and then we're dividing by 5. So 2y minus 7 is greater than or equal to negative 4/5. All right, this one actually is a special case, and you run into this situation where it's greater than a negative, and you don't really want to set up your two inequalities because at this point we want to stop and evaluate the situation. All right, so we see a greater than or equal to a negative number. That right there is our clue, because that happened when we were doing these. When we had something that was greater than or equal to a negative, we were always above that negative line. So were our solutions all real numbers. So if I write this out, the absolute value or the output of absolute value will always be greater than or equal to a negative 4/5, which means our solution is negative infinity to infinity. You can do your two inequalities, but you're going to end up seeing that they overlap because it's greater, so it's an or situation, and they're going to keep going. All right, but let's look at these special cases again. So if I isolate our absolute value, I would divide by 3, so I have 5 minus 9a in absolute value. It's greater than whatever negative 93 divided by 3 is. And we can do that in our calculator, but negative 93 divided by 3 is negative 31. And we just want to stop and evaluate the situation. So you can stop, pause. The absolute value output will always be greater than negative 31. If if it's always going to be greater than 31, I should make this grammatically correct, will always be greater than negative 31, our solution is negative infinity to infinity. This other example, example 8, I would multiply by 9 here to undo this division. But 9 times negative 1 makes that negative 9. We're not flipping our inequality because we didn't multiply by a negative. So we've isolated our absolute value, and we see that we're stuck with a negative there. That's where we want to pause and evaluate the situation. So the output of an absolute value will never be less than or equal to a negative 9. It's just never going to happen. The absolute value is going to always come out 0 or some positive value. So if it's always positive, it's never going to be less than negative 9, which makes this no solution. All right, the last thing we have here are just some word problems. And says that Maria wants to purchase pavers for her garden. She determines that each paver is within a 1/4 inch of the stated length of 16 inches. She will then line the pavers end to end with no space between them to create a straight path in her garden. Write an absolute value inequality that can be used to define the possible lengths of pavers. So if we think about what that means, really, let's put this on a number line. Our target goal is that the paver is going to be 16 inches. So it should be 16, but it says that each paver is going to be within a 1/4 inch. So we're thinking about there's some leeway between what that actual paver could be. So it could be within a 1/4 inch, which means if I subtract 0.25 or add 0.25, that's the tolerance level. That puts me at 15.75 and 16.25. And that's the inequality that we're really working with. So it's saying it could really be any of these values between here. But it can't be outside of that region because then it wouldn't have made it past quality control. So you see a lot of these types of problems in a quality control kind of thing where it has to be within a certain limit. And we can kind of dictate an inequality based off of that because our limit, the tolerance level, is 0.25. We cannot exceed 0.25. Sometimes we might call that like a margin of error. You can see that sometimes. But if we turn that into an inequality, what that's saying is it has to be less than or equal to 0.25. The amount that it's off can't be more, so it has to be less than or equal to. But really we're asking ourselves, well, what is it? What is it that has to be less than 0.25? And that is our absolute value. So the difference between the actual thing and the target value is what has to be less than 0.25. So if the actual thing was 15.75, it's only 0.25 off. If it was 16.25, it's still only 0.25 off. So we're looking at the difference between these two things, and the difference in math terms just means subtract. So if I have a specific paver, the difference between that and 16 cannot be more than, it has to be less than or equal to 0.25. So 16 was our target length, and the actual is going to be whatever the paver is. So we can let that be our variable x. This is how we would represent this in an absolute value inequality. So there's a few of these word problems to practice in the lab manual, as well as just a lot of these regular, no context inequalities.